All right, so in this video, I want us to talk about what nodes and antinodes are, and also I'm going to clear up a little something I said in some previous video. But when we're talking about waves on a string, and we have a string and it's resonating at one of its fundamental frequencies, let's say this one right here, whatever this one is. What is this? Let's see here. This would be the first harmonic, second harmonic, third harmonic, fourth. This would be the fifth harmonic right here. So here's a string resonating at the fifth harmonic. It's got these areas of what we call nodes and antinodes. A node is an area where the string would not move, which would be example right here at this little spot. The string isn't really going to move right there. So we call that a node, and we call this a node right here. We call this a node right here where it's not moving, node, and then of course it's got nodes at the ends as well. So those areas on the string, it's not moving, it's not oscillating. But here we have these antinodes right here. This is where the string moves the most. It's going to oscillate the most right here. So antinode, 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 and antinode. So here's all the nodes and antinodes on this string. You notice the fifth harmonic would have 1, 2, 3, 4, 5, 6 nodes. 1, 2, 3, 4, 5 antinodes. You're actually going to notice that all the harmonics on a string, there's always going to be one more node than there is antinodes. Okay? Now let's talk about harmonics in an open pipe. And this is where I'm probably going to clear up something that I said in another video. But let's draw I don't know which one this will be. Let's see. All right, so we'll use this harmonic right here. Let's see. Let's go ahead and draw the reflected areas. All right, so in an open pipe, every half wavelength is a harmonic. So we got the first harmonic right there, second harmonic, third harmonic. So this would be the fourth harmonic here. Now, in air columns, whenever we're talking about sound coming through the air, we're talking about areas of high pressure and areas of low pressure. So these areas right here that are in the middle, these would be a node, okay? So what's happening, here we go, I'm gonna draw the nodes real quick. What's happening here is these areas where there's a very big gap, those are gonna be our antinodes. Okay, so this is where the air is oscillating the most at. All right, so let's see here. So this area right here, the air is oscillating to high pressure, low pressure, high pressure, low pressure, high pressure, low pressure. Right here, it's also oscillating to high pressure, low pressure, high pressure, low pressure. A lot right there. Same here, high pressure, low pressure, high pressure, low pressure, high pressure, and low pressure. It's oscillating back and forth to those areas of high and low pressure right there. Now these areas right here where the nodes are, that's where the air pressure is basically staying the same. It's not really changing right there. Okay, so that kind of clears up something in my in another one of the videos. I said this is just an area of high pressure and this is an area of low pressure. That's not exactly true. This is actually just an area where the air pressure is not changing, and this is an area of high pressure, low pressure, and these are all areas of high pressure, low pressure with the antinodes. Okay, and same thing with a pipe with one end opened and the other end closed. So let's see here. Let's go ahead and draw it like this. And then we'll reflect it. So what harmonic would this be on a pipe? The first harmonic is every quarter wavelength. So every quarter wavelength on a closed pipe. So we got one harmonic, two harmonics, three harmonics, four harmonics. That's the fifth harmonic right there. And once again, we'll have our nodes here, the areas where the air pressure doesn't really change much. And then we got our antinodes here, antinode, antinode, and antinode at the end. So one thing you'll remember is the antinodes on pipes have to be in the open area. And if there's an area where, if we have it to where the antinode is not at the end of the pipe on a closed pipe, then it's not going to resonate. Same here. But one more thing too, I want to bring this up when we're talking about an open pipe. I've been drawing, in the other video, I drew all of the waves like this, but they actually can happen to be like this as well. Let's see here. All right, I'll draw that. Maybe clear up one more thing as well. And remember, in the other video, I said only the odd harmonics on a closed pipe create resonance. All right, so let's look over here, see if this is an odd harmonic or an even harmonic. So we got, and remember, it's every quarter wave. So we got a 1/4, 2/4, let's see, yeah, 1/4, 2/4, 3/4, 4/4, 5/4, 6/4 wave. So this is an even harmonic. So this is the 6th harmonic. But remember, every odd harmonic creates no sound. All right, which is kind of a weird thing because you're looking at this and you say, hey, but there's an antinode at the end. Yes, you're right. But the issue with that is that there's another antinode down here, and the two antinodes at the end cancel out because of this closed barrier right here. This area of high pressure, low pressure oscillation ends up canceling this area out too. So there's ends up being no sound coming out of this harmonic as well, even if you draw it with the antinode down here at this end. So that might clear up a few little things that I said in other ones, but it also talks about the difference between a node and an antinode on a string. Remember, this the area on a string. The antinodes are the areas where it oscillates the most. The nodes is where it doesn't oscillate at all. And when we're talking about sound and air pressure in columns and tubes, the antinodes is where the air pressure goes from high to low very quickly, and the nodes is where the air pressure basically stays the same. And then we also talk about this one thing over here, the closed pipe. Even if you draw it a little different way, the odd harmonics are always going to cancel out and still make no sound.